Hello, everyone. Welcome to today's webinar, Elevating Safety, our first webinar of our Innovation Spotlight series. My name is Sam Sakasiris. I'm the OSMINE Membership Manager for WA, and I'll be your host today. Before we begin, and on behalf of OSMINE and all of today's presenting companies, I'd like to acknowledge that I'm hosting this webinar from the lands of the Whadjuk Noongar people. We acknowledge the traditional custodians of the various lands on which we all meet today, and recognise the Aboriginal and Torres Strait Islander people attending this webinar. The Innovation Spotlight webinar series provides our members a way to showcase their groundbreaking solutions, techniques and technologies, and to see what the next phase of mining holds. Today we kick off the series with the Elevating Safety, delving into technology and innovation solutions in developing and implementing cutting-edge safety equipment, wearables, and real-time monitoring systems, to name just a few. I'm joined by 4 industry-leading member companies sharing their technology and innovation solutions for zero harm mining. Joining us to share their expertise today is Tim Snell from Pitcrew AI, Marcus Velastro from Corehesion, Matthew Cook from Hawk Measuring Systems, and Penny Crawford from Crawford Boots. The format of the webinar will include a short presentation by each of our presenters, followed by a Q&A session. If you have any questions for the presenters throughout the webinar, please type them into the Q&A box at the bottom of the screen. If your question is directed to a specific presenter, please note their name in your question. This webinar is being recorded and will be shared with all attendees. So that concludes the intro and welcome. So without further ado, I'd like to welcome our first presenter, Tim Snell, CEO and founder at Pitcrew AI.
G'day, everybody. If you've been in the mining industry for any period of time, you've probably heard about tragic, fatal accidents involving the large tyres of haul trucks. OTR tyres, the off-the-road tyres of haul trucks, are recognised as a critical safety concern on every mine site. There's inherent risks in dealing with tyres, firstly because they're extremely large and heavy. They operate under high pressure and a massive pressure vessel, and they also contain materials that can catch fire. So it's crucial that we can manage these risks to prevent further incidents on mine sites. One of the largest risks that we come across is tyre fires. As the tyre rolls down the haul road, sharp rocks or other debris can cause small cuts in the top layers of rubber. And as dust and grit and water work their way into the tyre, it starts to rub and generate friction and heat. Because of the huge loads that these sort of tyres are under, it can start a process where heat starts to build up between the layers of rubber faster than it can escape, and you end up with a feedback loop where the layers start to separate. In a best case, this will just reduce your tyre life, but in a worst case, this can move into a tyre smoulder, a tyre fire, or even a tyre explosion. Now, in the event of any kind of smoking tyre or smouldering tyre event, it's basically treated like an explosion risk. So the vehicle will be isolated with a 300-metre radius exclusion zone around the vehicle in case there is an explosion. Obviously, hugely disruptive to site operations, but absolutely critical to ensuring safety of the people on the site. So detecting a heat separation before it becomes a critical safety risk is obviously really, really important. And it's a challenge that's been faced by the industry for decades. The current processes involve downtime for the vehicle and routine tyre inspections. But this presents its own challenges, firstly because heat separations aren't obvious. They're within the tyre itself, so they're quite difficult to see by eye. And secondly, because access, if you're a human looking at a huge tyre, you may only see the front or back of the tyre. You're not necessarily looking at the top or the bottom. You're only able to see a small fraction at any given inspection. So that's where automated inspection has come in. As you can see here on this video, on the second from the right tyre on the back, you can see a hotspot rolling around there. This solution uses advanced thermal imaging technology and AI system trained on many tens of thousands of images of mining haul trucks to identify heat separations forming in mining haul truck tyres that would otherwise be invisible to the eye. This sort of technology can help to prevent tyre fires because we can detect issues days or often weeks in advance of it actually becoming a safety reportable incident. By using automated inspections, we're able to increase the frequency that inspections occur and reduce the number of manual inspections required. So reducing overall human to vehicle interactions, removing people from harm's way. The way we deploy this is as a fully self-powered, self-contained skid or trailer at the side of the haul road, including multiple sensors, cameras, weather station, and Starlink radio. This provides a lot of flexibility in where a solution can be placed on the site and able to get the most effective coverage for a fleet, being able to view every vehicle multiple times per day. We've now deployed these systems across the world, everywhere from the Pilbara to Chile to the very cold Canadian oil sands. So we've got many years of experience in deploying a robust hardware set for automating inspections. So this gives an indication of what a typical workflow might look like involving automated tyre inspection. So after a vehicle passes the skid, if damage was detected, an alert could be generated via email, SMS, or automatically generating a work order for inspection. The technician or tyre bay or maintenance planner would then be able to view remotely what has been identified and then plan for a manual inspection. Obviously, aiming to do that in a safe manner because you've got a better insight as to what's actually coming into the inspection bay. They're able to view those images and videos and then actually perform the inspection. This is kind of the first time that tyre bays have had real-time condition monitoring data from what's going on out in the fleet. Tyres are a really high-value asset on every mine site, but before this sort of technology, the condition monitoring available was really limited to manual inspections carried out by the tyre bay periodically. The dashboard view on the right shows a fairly standard top-down view of the trucks in the fleet, and then a very traditional traffic light color coding system for managing sort of risk levels on individual tyres. So if we think about the health and safety hierarchy of controls, elimination's right up at the top of that list. So this solution really aims to eliminate many of the risks associated with working with OTR tyres. Firstly, by reducing the number of human vehicle interactions, and then by totally eliminating some of those high risk items such as hot tyres and tyre fires. So thanks everyone for your time.
Thanks very much, Tim. Yeah, some great innovation and technology there being used for a common issue on the sites. Next up, I'd like to welcome Marcus Velastro, Innovation Manager at Corehesion.
Good afternoon, everyone. So my name is Marcus Velastro, and I am the Customer Innovation and Success Manager at Corehesion. So Corehesion is an integrated software ecosystem of management functionality, which covers work, equipment, people, safety, and contracting. Each component you see here within these modules can be seamlessly integrated to leverage another component and enhance the overall functionality across the platform. Today, we'll be exploring how Corehesion platform empowered the digital transformation of explosive dust management. A coal dust explosion is one of the most significant risks in the harsh and complex environment of an underground coal mine. The primary defense is stone dust, which, when systematically spread throughout the mine, saturates the coal dust and renders it unable to combust and spread spontaneously. So some facts. 290 people have died from underground coal mine explosions in Australia. There's been over 10,000 underground coal mine related deaths in the USA. As recent as 2020, 5 people experienced life-altering injuries from an explosion in Queensland, And last year, 41 people perished in an explosion in Turkey. Yet, my research shows that there have been few advancements in the managing of this risk over the past 90 years. Queensland's regulatory findings support these significant gaps in the management of dust across the industry. The audit found that there was a gross inconsistency in sample labels and sample results from the laboratory. There was no records observed of redusting locations and results, generation of coal dust at different locations, or what the required application of stone dust was. Where a stone dust application rate was provided, the rate was based solely on past experience. The application of stone dust details were not detailed in the standard operating procedures, and no study on coal dust fallout had been done to decide the optimum rate of application of stone dust at different sections of mine roadways. So we partnered with a major global miner who was seeking cutting-edge ideas and technology to transform their approach to explosive dust. What we found was that the existing approach to managing stone dust application and dust sampling was difficult, time-consuming, and inconsistent. They were reliant on paper-based tracking sheets and individuals for continuity. It was difficult to ensure and prove regulatory compliance, and their processes were reactive rather than proactive. What we wanted to achieve was to automate steps in the process and reduce manual processing, provide a single, readily accessible source of digital records relating to samples, results, and retreatment, enable a proactive approach to the planning of stone dust application, ensure safety and easily demonstrate compliance, and reduce costs associated with oversampling, overdusting, and labour of failed redusting. There are many components to explosive dust management to achieve these objectives and rectify the partner site and industry difficulties. Previously, all of these components and processes were very separate. So managing sampling routines and plans, access to historical sample records, recording routine dust applications, and responding to result failures were in all different systems, Excels, paper, Word. In order to look at utilizing data and optimizing stone dust application rates, we needed the integration of all of these critical components. So what we did, we integrated with the mine's AutoCAD to create a digital twin of the mine to base samples off. This allows for easy management of zones and improves data integrity through name standardization. To automate steps and reduce the chance of manual error, we automatically generate sampling plans and labels for a given week based on previous sample history for a zone and its current regulatory sample requirements. So samples are made up of 70%, 80%, and 85% zones, which is the total incombustible content, TIC percentage, which is essentially just the proportion of stone dust to coal dust. A higher TIC percentage required in one zone location is due to the larger coal dust generated in that location, such as at the face. So data from Corehesion EDM module is directly integrated with the laboratory systems for sample results. We created the ability for users to easily capture stone dust applications through either desktop, mobile, or tablet, which was previously paper-based. This also automatically determines if enough stone dust has been applied to a location based on the production area classification of that location, and will indicate to the users whether it's failed or passed. With this data capture and integration, there are large benefits in data visualization. So sampling failures and stone dust application failures are displayed, allowing the user to easily identify compliance and drill down into the detailed problem areas. And the heat map, as you see there, enables users to view the frequency of non-compliant sample results in a way that's easy to interpret at a glance. We initially provided the ability to set minimum dust application rates for each production area to ensure stone dust applications met the set compliance parameters. So previously, the minimum dust application rates for zones were handled completely separately to how frequently that zone should be sampled and what the minimum TIC percentage is for that zone. So despite this separate management, through research, it was obvious that there was a relationship between how much stone dust should be applied within a zone, i.e. its application rate, and the sampling requirements of that zone. So one of the critical enablers to connect this stone dust application data and sample results was to create a relationship between these minimum dust application rates and the sampling frequency and minimum TIC percentage of a production area. So we established that relationship there. When zones have failed, results based on our integration with the laboratory or a stone dust application has been captured in our system has failed to achieve the desired minimum application rate, the failure will appear on this live map, which is shown on a large TV in the muster area. It will instantly provide the required dust for reapplication and allow users to capture the redusting. The dust required for a failed sample result is calculated based on how far away the TIC percentage of that result was from the compliance target, which may be more or less than the blanket rule commonly used for redusting of 20 kilograms per meter. With all this data now integrated, using historical dust application records in combination with sample results allows for the performance measurement of these application rates. Never previously was there a way to view the performance of a particular application rate, and therefore these rates largely remained the same across different mines and production areas despite their varying conditions. Finally, we can correlate all the dust application rate performance over time against the associated minimum incombustible content to allow for optimization of application rates for a production area. To determine this, the suggested optimal minimum dust application rate, a simple feedback loop is used. So the proportional percentage difference between the result and the compliance target is calculated to measure the error of each singular sample result. And then this error is just multiplied by the existing minimum dust application rate over time to suggest a new optimal rate. So what's next? Standardization for use at other underground coal mines. Then we're going to investigate a portable measuring instrument for instantaneous results. With more historical data, we'll be able to improve the optimization method. And in the future, there may be scope to integrate other vital risks into the system to improve their management and visibility. Thank you, everyone, for listening.
Thanks very much, Marcus. Much appreciated. Great presentation. Next presenter I'd like to welcome is Matthew Cook. Matthew is the Product Manager, Fibre Optic at Hawk Measurement Systems.
Hi, everybody. So today I'm going to give you a quick introduction to the Praetorian fibre optic sensing system for conveyor health monitoring systems. So those are a fibre optic distributed acoustic based system for looking after all of the idlers on conveyor belts. So Hawk's a instrumentation specialist. We've been going since about 1988. We've primarily worked in the mining industry. We have our own in-house R&D and manufacturing down here in Melbourne. And we have the Praetorian fibre optic sensing system as kind of our flagship product at the moment, which is used in all sorts of applications. But today we're just going to talk about conveyor health monitoring. So who am I? My name's Matt. I studied mining engineering at UNSW. I've been done work on surfactant and froth flotations for research projects. I've worked for Hawk for just under 10 years now, and I've taken a variety of roles in that time. I probably don't look quite as youthful as I do in that photo anymore, though. Okay, so I guess why monitor conveyors is the first question. So conveyors are inherently large, difficult, high maintenance, fairly dangerous objects, but they're pretty much the only way of moving bulk solids around a site. So as part of that, conveyors have the ability to fail, to tear, to rip, to burn. They have the ability to have idlers split and rip the belt for hundreds of meters before detection, potentially catching fire and causing issues throughout. So the idea is that we want to be able to monitor these idlers. So the status quo currently is a manual inspection. Depending where you are in the world, that manual inspection may be legally mandated. So if you're at a underground mine in Queensland, for instance, it needs to be checked by a superintendent level at least once per shift. So that'll cover the statutory requirement. It'll also catch other maintenance issues, and it creates operator familiarity with the equipment. The disadvantages, though, is that if you take two conveyor inspection superintendents and you have them both inspect the same belt, you'll end up with drastically different results. It is a monotonous manual task. Any task that is monotonous and kind of observation-based is inherently not very good for humans to be doing. Not just anyone can do this. this kind of inspection work. The reason for that is that you need to understand what the noises you're looking for and what you're trying to find are actually there. It's also fairly costly in terms of the amount of maintenance it requires. It requires scheduling. It may require once per day, once per shift. It also puts people nearby conveyors, which is generally not something you're wanting to do. So you're definitely starting to get close to putting people within the line of fire. So the solution we'd like to introduce is the Praetorian fiber optic sensing system. So the way this operates is it effectively turns a fiber optic cable that you would normally use for communication into a series of microphones. It does this through a couple of processes. If you'd like to do your own research, there's Rayleigh backscattering and time of flight. But effectively, every 500 millimeters, we are turning the fiber optic into a microphone, a contact microphone. We take this information every minute or so, and we analyze the signals within those vibrations to detect faulty idlers. So we're able to detect idler faults roughly 20 days in advance, and we're comparing that to manual inspection methods. So we're typically finding that someone's able to see, if we give an indication that an idler is on its way out, because we're giving 20 days of advance notice, you're actually able to plan for your next shutdown, which idlers you should be looking to pull out. The reduction in belt walk back to from the belt walk, which is a full length walk of the belt, really becomes a more detailed point check. So you have your list in the morning. The idea is it comes in before you start your day via email. You'll get a list, which I'll show you in a second. You get a list of idlers that are problematic. You go and inspect just those idlers, and it saves you a lot of time and a lot of effort. Really, the big ability is for it to detect and prevent things like conveyor fires occurring due to hot idlers as well. When you're looking at different configurations, you can have multiple units stack up. Each system's capable of handling a 10-kilometer length of conveyor. It can handle multiple conveyors if you kind of daisy chain them together, one after the other. And you're able to actually link these systems together with local servers to a single graphical information system overlay, like a graphical user interface, similar to what you'd get on Google Maps. So you imagine dropping pins on maps to give you an indication of problems. So in terms of what the solution looks like, there's a casing-based solution. So there's actually a fiber optic cable inside that case that runs along the inside of the conveyor belt that you can see there on the left. And then on the right there is effectively what the solution looks like. So it's really two parts. There's the internal component, which is really a rack-mounted PC that's been modified to allow fiber optic communication interrogation. And then you've got all the field components, which is a solution that's generally custom designed for your site. This solution would be able to be put into either side of the belt, giving you left or right indication, telling you where the fault is within an idler or so. And it also mechanically protects the fiber as well from any impact or anything like that. Insofar as what the example output looks like, this is the kind of, we call this the 5 a.m. report, 6 a.m. report. So the idea is you sit down with your coffee in the morning and you get a report of what your idler looks like. We give you the frame number, whether it's the left-hand or right-hand side. We give you the current priority and the previous priority. So if it's accelerating, you might see this go from a priority 2 idler to a priority 1 idler. We give you the fault range if there's a lot of concentration of sound in that area, and we can actually give you the date that we first saw this issue. So if there's an idler that starts getting loud and it's been loud for a while, it may go into a stable condition. So there's a whole bunch of different ways of presenting the information, but this is the typical one that we have for most people.
Thanks very much, Matthew. Another great presentation there on the safety initiatives that are going around, which are fantastic. Finally, it's my pleasure to welcome Penny Crawford, Managing Director at Crawford Boots.
Great, I think I'm on. Thanks to Osmine, and also congrats to Tim, Marcus and Matthew for those fantastic presentations and innovative safety solutions. I'm Penny Crawford, and I'm the founder and Managing Director of Crawford Boots. I can't think of a better way to start this presentation than with a video from the 2019 New South Wales Minerals Council Health, Safety and Innovation Award, which we won in conjunction with Whitehaven Coal. Danielle, would you mind playing that video for me, please?
The good thing about the Crawford boots is that they can be tailored to each foot.
The typical gumboot doesn't fit. So the Crawford boot addresses that fit issue with my Wedge Tech Lock Fit system, which is an insert that sits in the pocket at the front of the boot, and basically it tailors the fit to all different foot shapes and sizes.
So usually I just wear the normal gumboots underground and I end up with sore ankles.
So it's a bit of a sports shoe type setup. It's not as sloppy as the traditional gumboot. So you could really say it's like a Nike of the gumboot industry.
Thanks, Danielle. Okay, as you can see from the video, Crawford boots are next generation waterproof safety work boots that have been designed by myself, a podiatrist with over 27 years of experience. The reason for the development of the boots was when I was working as a podiatrist, I was seeing firsthand the damage, the injuries and the safety concerns occurring with my underground mining patients that were directly related to their ill-fitting gumboots and their work environment. So I realised pretty quickly I couldn't change their work environment, so I needed to build them a better boot. To be honest, I was a bit amazed to see that my patients were still wearing gumboots that I think my grandfather or my great-grandfather would have worn. And especially in a time when we're seeing such high levels of innovation in other areas of footwear, say, for example, the jogger, why hadn't there been any such improvements in the gumboots? So prior to Crawford boots, the underground miner had the option of a leather lace-up boot or a gumboot, and both these options were unsuitable. The gumboots were waterproof, but they were ill-fitting, so they caused injuries, and the leather boots, whilst they gave that great fit and comfort and stability, they weren't waterproof, so they wouldn't last in the harsh underground work conditions. So I realised I needed to build them a boot that gave them the best features of both, the fit, the comfort, the stability of the leather boot with the waterproof capabilities of the gumboot. What I like to do is think of your feet like they're the foundations of your house. If there's problems with your foundations, you'll see cracks start to appear, maybe not immediately, but you will over time. The same thing occurs with the feet and the human body. If your foot is secure in a boot, your balance is increased. You've got less overuse on the muscles and the joints. You'll have less chance of slips, trips and falls, less fatigue and less chance of injuries. And that's the whole mission and purpose of Crawford boots, is to reduce that likelihood and the severity of injuries. Okay, so there's a couple of things that make Crawford boots unique. As you saw from the video, the Wedge Tech inserts, and they have been granted an inventive patent in Australia, New Zealand, Europe and Canada, and also a design patent in America. As you saw, as I said from the video, the inserts enable the wearer to tailor the fit of the boot to their individual foot shape and size. So basically it secures the foot in the boot. There's also a few other differences. In each boot, there's 23 individual pieces of rubber, as opposed to a gumboot with one sheet of PVC. We've got reinforcement around the heel area, and what that does is it's really good for ankle support. We've got reinforcement across the top of the boot, which is great for metatarsal protection. The boot's aligned with what's called Microban ZP Tech, which is antimicrobial, antifungal neoprene, and that stops the rashes that occur with, you'll see skin irritations and rashes from the gauze in gumboots. The boots also have a zipper, and that zipper is enclosed in a waterproof gusset. So the zipper allows ease of access for getting the boots on and off, but also you can wear it with the zip open. You've still got the fit and the waterproofness, and it allows for those larger calf muscles. The boots are safety certified to the highest standards that are compliant with working in any mining operation. And Crawford boots, basically my aim was to provide a safe, stable and solid foundation, and then that would result in a reduction in injuries. $150,000 is actually the financial cost of one ankle injury, or can be one ankle injury to an operation. So we're talking financial cost, but that doesn't take into consideration the physical and the emotional cost to that individual or that workforce team. Last year, I attended the Queensland and the New South Wales mining health and safety conferences, and one of the major topics of discussion was the impact of safety hazards and psychosocial hazards on a mining operation. The call to action for mining organisations to become more proactive rather than reactive when considering the safety of their workforce, and the question was, how can you afford not to? It was interesting because fatigue was recognised as one of these psychosocial hazards, and to me, walking day in, day out underground in a gumboot is the equivalent to running a marathon in a pair of thongs, so I would call that fatiguing. With over 20,000 boots sold nationwide over the past 5 years, we've had the opportunity to work with many mining organisations and teams that are strong believers in being proactive and are receptive to different options and safety solutions. To demonstrate this, I'd like to just share a conversation I had with the procurement manager of a large underground coal mine last week. They've been using the boots for 2 years now, and initially they restricted the access of the boots to problem feet, but they saw such a marked reduction in foot and ankle injuries that they broadened that application and developed further safety improvements. So they now offer the boots as free issue for any person working at any of those sites. And as a large mine with over 1,000 employees, they've actually seen the data that some additional upfront cost is more than offset by the level of injury reduction, the comfort the boots provide, which improves the employee attitude, and the longevity of the boots outlasting all other boots. So these were the words from the procurement guy, not just the safety team. Crawford boots, they've progressed from being a special boot to the best boots for everyone. And I think they're a great example of how a simple yet innovative solution can and will elevate the positivity, productivity and safety in a mining workplace. Thank you. The last slide is my contact details. If you wouldn't mind popping those up, Danielle, that would be great.
Thanks so much, Penny. Great to see innovation and technology coming to the gumboot, which is, and as you said, pretty important part of the body on a site being the feet. I do have, that's the end of the presentation. I've got time for audience Q&A. If you haven't already sent in your question, please use the Q&A button at the bottom of your screen. I've got a couple here that have come through. I'll start with Tim from Pitcrew. The question is, if our fleet has tyre pressure monitoring system, how does this solution differ?
Yeah, okay. So tyre pressure monitoring systems, TPMS, have been adopted by industry probably over the last 5 to 10 years and are really effective for detecting some types of tyre overheating events. So basically, there's so much thermal mass in a tyre that the temperature inside the chamber where a TPMS sensor gets mounted can be quite different to what's happening on the tread of the tyre. And what we have certainly seen is that a lot of the tyre fires actually start to occur in the tread of the tyre, where TPMS won't pick that up until typically, minutes or seconds before a fire breaks out. What TPMS is really effective for is spotting overwork-induced heat issues. So if you're pushing your ton kilometers per hour with your vehicle really hard and you want to be derating that horse speed, for example, TPMS is really, really powerful for that application. But when it comes to actually detecting heat separations and tyre damage in the tread pack, TPMS isn't really fit for purpose for that. So our solution is really complementary to the TPMS offerings that are out on the market.
Great, thanks very much, Tim. Marcus from Corehesion, question for you, please. What would be the process to implement this explosives dust management module at another mine?
Yeah, so after understanding how that mine currently manages their dust, of course, understanding that, most likely first we would set up a basic digital twin of the mine. So either using their existing an AutoCAD file or something else, or we could create one suitable for that mine. Then it would just be configuring production areas in our system, which are in line with that particular mine's standard operating procedure. So setting up those production rates, those sampling frequencies for different areas suitable, and that can change as we throughout the process. Then we'll just need to configure different locations of the mine on that digital twin to be a certain production area. And then the hardest bit always is just the change management at the end and training and getting everyone else on board, which we would then provide full support for.
Thank you very much. Matthew from Hawk, one for you, please. Where has this technology been implemented?
I handed over a project in a major power plant in the Hunter Valley last week. We had a 7-kilometer run there that's monitoring something like 12,000, 15,000 idlers over 3 kilometers. And yeah, so if you're in New South Wales right now, my system's monitoring what's running your power.
Very good, well done. Penny from Crawford, one for you, please. Obviously, you've got a fantastic product and there's proven benefit there to the workers, but we do know that mines aren't great at change. How did you overcome this resistance, both corporately and at a site level?
Thanks, Sam. Yeah, change management's always interesting, isn't it? I think there's 2 different approaches. Usually at a site level, it's become word of mouth that people have heard about the boots and there's that positive feedback and reaction. Part of what I do is I go to site and I help fit the boots, do toolbox talks. I suppose of the fact that I've been a podiatrist for 27 years, I'm speaking about something that I know about, so they value that. Then obviously it's all about the trials. The trials, the feedback, when they get the runs on the board and get the reduction in the injuries and the customer, dare I say, satisfaction, it then sort of moves on. And it's word of mouth. Like, it's a very small industry. Like, once you get some runs on the board with one company, often it becomes, and they tend to move around from company to company. They then take the boots with them to the next.
Fantastic, thank you. Tim, back to you, please, at Pitcrew AI. What is the ideal frequency of inspections during the day?
Yeah, so we'd be aiming to see every vehicle at least once per day, but ideally probably 3 or 4 times per day would be great. Just because of, we're still limited by the physics of the situation, and if we had heavy mud coverage, for example, we would want to get a clean scan, ideally once per day, in order to get good tracking.
Thanks very much. Marcus, back to you, please. What other hazards could be managed in Corehesion?
Yeah, so for example, functionality could is there to raise geological or mechanical hazards, which could be graded depending on a determined risk. So these could be raised on desktop or mobile, and easily display on that existing live map. So as part of that, which is already there with the explosive dust module, and it could reveal more information and photos for those on the surface. So easy to raise awareness and help planning and safety. And then if it was further integrated with our planning and scheduling system, the schedule could be automatically adjusted based on the location and the grade of another hazard or risk.
Thanks very much. Matthew at Hawke, just how many conveyors can the fibre optic system handle simultaneously?
It's not limited by the number of conveyors, it's limited by the length, total length. So a single interrogator can handle up to 10 kilometers of conveyor run. So typically 1 or 2 of these systems will do an entire site, even if you've got some substantial overland belts. And one of the post-processors is able to handle up to 5 interrogators. So without having to repeat any material, you'd be looking at up to 50 kilometers of conveyor belt.
Thank you. Penny from Crawford, you state the boots last longer than traditional gum boots. Have you done trials to demonstrate this?
Thanks, Sam. Yes, we have done trials, and that's often the way that a mining operation starts with the boots, through a trial period, picking out the ones for the people that do a lot of walking that may have had injuries in the past, and using the boots. So from there we get the feedback, and what we've found is that there has been, sometimes they're outlasting other boots by 6 times. Like a mine I was at last week, they go through, often their workers will go through 1 pair of gumboots a week. So the Crawford boots are still there after 6 months in the same pair. So yes, the longevity is done through obviously feedback from the trials.
Fantastic, thank you. Tim at Pitcrew, back to you. Can you detect other issues within the fleet rather than just tyre failures?
Yeah, so at the moment, the automated inspection is really focused on tyre inspection, but we're certainly able to identify lots of other issues on vehicles. We've had situations where we've identified everything from oil leaks, issues with final drive and braking units, and hydraulic and fluid issues on the vehicles as well. So, but in mechanical systems, basically anything that's going wrong generates heat, and the thermal imaging technology is really effective at identifying those issues well in advance of them becoming a major problem.
Thanks very much. Marcus from Corehesion, one for you, please. What are further optimization methods that you could do?
So we're a little limited by data at the moment, but with the data we're building, and if more live data underground becomes available of different environmental conditions, the feedback control could potentially be advanced to proportional control or proportional integral control, and perhaps even PID control. But it'd be more beneficial if there's like an effective stone dust application actuator to spread dust, and perhaps it could be automatically applied at a continuously updated optimal rate. Currently, the rates still require someone to kind of approve the new rates before they can be used. So yeah, as we get more data, probably those are the main methods we would look at.
Thanks. Well, I've got you, Marcus, another one. You mentioned there's many modules within Corehesion. Are there other ones that help with safety?
Yeah, so a large focus for Corehesion is kind of finding that balance between safety and productivity. And fortunately, through simple digital transformation and integrations with other systems, we've got lots of modules that improve both safety and productivity at the same time. So some examples are probably our contractor management module. So that can prevent contractors from doing jobs which they're not competent for, and speeds up the process as well. Also our asset compliance module, which provides greater visibility of equipment compliance and has digital inspections. And yeah, there's a ton in as well.
Thank you. Just a couple more for Matthew from Hawk. Can you tell us or run us through what's involved with the installation?
Yeah, no problem. So effectively, a fiber optic cable is pulled along the length of the return belt. Those are then adhered to the side of the stringer via a casing-based system, which generally uses just a pretty standard bolt mechanism. That casing ensures that the fiber is held evenly against the structure so that there's no differences depending on the installation method. So it's all pretty straightforward. We're getting responses that teams of 2 are able to knock out about 300 meters per crew per day in a 12-hour day. So we're starting to see some pretty good results in terms of install speed. So typically these are done during maintenance shutdowns, regular scheduled shutdowns.
Thanks, Matthew. Well, I've got you. Who is the original equipment manufacturer of this system?
So these are designed, manufactured, sold and supported directly out of Melbourne. So that would be us. So if there's questions about customization or anything like that, absolutely able to be done. So if you want email warnings, if you want SMS warnings, if you want push notifications about your idler conditions, those are all available as something we can build for you as the OEM.
Fantastic. Thank you very much. That's all the time we have for the questions today. If we did not get to your question, please reach out to the Osmine team and we'll put you in touch directly with the respective presenter. If you enjoyed this webinar and you would like to continue the Innovation Spotlight series with us, register for our next one, which is the Rise of the Machines, coming up on the 25th of March. and of course the rest of the series. Thank you everyone who attended. We look forward to welcoming you to the next Osmine webinar. And finally, I'd like to give a big thank you to our presenters today, Tim, Marcus, Matthew and Penny, for sharing your expertise. Thank you everyone and enjoy the rest of your day.